Welcome to Manufacturing Processes, Machining and Machine Tools lectures by Professor Joyjeet Ghosh. This is the 10th lecture of a series of lectures. This lecture will be on Shaper Machine Part 2. He will be discussing about the hydraulic drive mechanism, shaper feed mechanism, shaper operations, cutting speed, feed and depth of cut of shapers. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access my videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this part 2 of the Shaper Machine lecture. So in this lecture we'll be discussing about the hydraulic drive and we'll discuss the cutting speed, feed and depth of cut on a Shaper machine and what are the different operations that are performed on a Shaper machine. So let's start. In hydraulic drive, what happens? We have a hydraulic cylinder. This is the hydraulic cylinder. This hydraulic cylinder can be fitted inside the ram or maybe outside. It doesn't matter, but we should have a hydraulic cylinder. Now notice that there is a piston rod here and there is a piston. This is the piston here. This is the piston. This is the piston. Sorry. This is the piston here. Okay, and this is the piston rod. This is the piston rod. Now this piston rod is attached to the ram here, and in this cylinder, this is a cylinder. Try to imagine this is a cylinder. This is the left side and this is the right side of the piston. This is the left side and this is the right side of the piston. We'll refer to as right side and left side. Okay, now during the forward stroke, what happens? And there is a valve here. This is a four-way valve. Four-way valve. The valve is now a black box here. I have not shown the valve positions here. Now at this forward stroke, pump will, there is a gear pump normally used. Pump will pump oil from the tank to the right side of the piston. So when it pumps oil to the right side of the piston, it will fill here rapidly and it will apply pressure here and the ram will move in this direction. During the time it was applying pressure here, there was oil, hydraulic oil here. This hydraulic oil will flow back from here to the tank. During the forward stroke, this is the pipe through which it was reaching and it is reaching through this pipe. At the end of the stroke, there is a reversing lever which reverses this position of the valve, and now what happens? Oil from the pump will reach in this to the left side of the piston, and oil from here will come and reach the sump here because of the valve position. Now as the oil is pumped here, it will move in this direction and the ram will return. So this is how it is taking place. Now why this is a quick return mechanism is because this the area of cross section area here and the cross section area here has a difference. If this is A2, if this is A1, so V is equal to V1 A1 is equal to V2 A2, we know from continuity equation. So therefore, see, A1 is high and A2 is low. A2 is low because some of the area is occupied by the piston rod. Piston rod is deliberately made larger so that the A2 is decreased. When A2 is decreases, this remaining constant, the discharge Q remaining constant, so V2 has to increase. Therefore, the return stroke is faster. So this is how quick return mechanism is achieved. Now there are some inherent advantage of Shaper machine. Look at the graph. So here we have a fairly constant velocity. This is actually ideally wanted in a machining. You want a constant cutting speed. and return state is faster, but still it is constant. Whereas in a mechanical shaper, it was somewhat like this. This is the return forward stroke, and the return stroke was higher, like this. So it is much more better surface finish is given in shaper machine, in hydraulic drive. And also what happens in a hydraulic drive, because of the hydraulic present on the other side during return stroke, it has a cushioning effect. Whereas in a mechanical shaper machine, there is jerk at the end of each stroke. But here at the end of each stroke, since there is hydraulic on the other side of the piston, so there is a cushioning effect. And you can vary infinitely in hydraulic drive the ranges of speed. The speed can be varied infinitely by varying the discharge, and we can vary the speed, area remaining constant. There is a relief valve, and if the pressure somehow increases more than the design pressure of the hydraulic oil, the relief valve will open and the machine will stop immediately. So there is the inherent safety features in hydraulic drive. So obviously hydraulic drive is much better compared to the mechanical drive, and of course it is much more costlier. Now let's see the working of the valve. Working of the valve I have not explained here. So here this is the valve here, four-way valve. This is the four-way valve, and you can see this is attached to a reversing lever, and there are stops. The distance between these two can be fixed to decide the length of stroke. Now what happens during the forward stroke, as it is moving forward, this is going, this is hitting here, this will hit this top, and there is it is pivoted here. So once it hit this, so this will move in this direction. So once this move in this direction, this position of this will be somewhere around here. This will be somewhere around here. Now initially the oil from this was flowing here to the right side. If this is the right side, this is the left side. So oil was flowing here, and oil from here is coming down, and it was flowing here to the sump. Now what happens? Now this comes here, the oil from the pump reaches here, and this oil from here reaches to this position. So this is how reversal takes place. Again at the end of the stroke, this will move forward, and this will come again to the proper position. So this continues. So this is the working of a hydraulic drive. Okay, shaper feed mechanism also we'll be discussing. In a shaper machine, this is a mechanical shaper. You can see from the bull gear, this is the rod on which the bevel gear was mounted, and you can put the handle and you can change the length of stroke. Now eccentrically to this, you can mount this connecting rod to a disc here or a gear here, and this is the indexing pawl. Sorry, this is the pawl. This is a sorry, this is a pawl. Working of this I will discuss. Just try to understand. See, this is eccentrically loaded to a disc, and there is a connecting rod which is connected to a rocker arm, and the rocker arm has a pawl like this, which has a slanted on one side and straight on one side. See, this is straight on one side and slanted on other side. You can change it. You can change by lifting this, and you can rotate it, and you can change the position of this from this direction to that direction. It doesn't matter. It indexing ratchet, it fixes to a indexing a wheel. This is a wheel on which it is fixed currently. So this is the diagram which will be explaining. So this is driving disc. This driving disc is rotated by the rotation of the bull gear. As the bull gear rotates, the driving disc 8 rotates. Now on this driving disc 8, eccentrically, a connecting rod 9 is fixed to this driving disc. So if this is rotated, so the connecting rod will reciprocate. Okay, so this connecting rod is fixed to the rocker arm at 7, and which is pivoted at this 6, and on this 6, this ratchet wheel, this is a ratchet wheel, is fixed on the cross slide lead screw, on the cross slide lead screw. So if this rotates, the cross slide lead screw will rotate. And this is the rocker arm. There is a spring loaded pawl here. This is spring loaded pawl here. Currently it is fixed in this position Now what happens during the one half of the rotation, this will rock in this direction, this will rock in this direction, the rocker arm will rock in this direction. Now, as this rocker arm rocks in this direction, this is a slant edge, so this will slip over these teeths, and during the second half of the rotation it will rock in this direction. So when it rocks in this direction, it is here we have a positive drive here, this is straight, and this will rotate in this direction. As this rotates in this direction, this shaft will rotate and the cross slide will rotate, giving a feed to the table. That means the table will move according to with respect to the cutting tool, and a feed is provided to the cutting tool. So this is how a shaper feed mechanism of a shaper works. What are the shaper operations? I am not going into details of the operations. These are practical aspects. You might be doing, you might have done it in the practical, or you might be doing in the practical. Measuring a horizontal surface, measuring a vertical surface, measuring inclined surface, cutting slots and keyways. Okay, now the cutting speed, feed and depth of cut. Now the cutting speed, before we go into that, so what is the length of work, or what should be the stroke length? If this is the length, let's say this is the length of the workpiece. This is the length of the workpiece. Now we start slightly ahead, which is called approach, and slightly over travel, that is called over travel length. So total length is equal to LA plus L plus LO. So normally we take around 25 mm as approach length and over travel length. With this knowledge, we'll move on and we'll discuss, we'll find an expression of the cutting speed. It is the speed with which the ram reciprocates basically, and that can be found out by finding the length of the cutting stroke. It is expressed in this L that we have found out in the previous slide. It is in mm, so we convert it into meter by dividing it by 1000. So it is L by 1000 V. So time taken by the cutting stroke will be L by 1000 V, or V is equal to L by 1000 T, and T is the cutting stroke in minute. And we normally it is provided, this data M is provided, return stroke time by cutting stroke time is equal to M. So we after the cutting stroke time, we can find out the return stroke time. The return stroke time plus cutting stroke time will be the double stroke time. So if we can find out the double stroke time, 1 by double stroke time will be the RPM. From that we can find out the velocity. So return stroke time will be M into the cutting stroke time. So then the double stroke time will be cutting stroke time plus return stroke time. So it will be L into 1 plus M by 1000 V, and reciprocal of this will be the RPM of the bull gear. So N will be this, and from this expression we can find out V is equal to this. Feed as relative moment. So in this case this is the feed. Let's say this is the feed. See, it is cutting in the forward stroke, and during the return stroke the workpiece will move slightly in this direction, and how much it moves per double stroke or per cycle or per revolution of the bull gear is called the feed of a shaper, and depth is the distance, perpendicular distance between this surface and this surface is called the depth of cut. And to find out the machining time, we require let's say this is L considering the approach and the over travel. Also P is the breadth considering the approach and the over travel. So in one pass it will be cutting here. So how many passes will be required to complete the entire breadth? To complete the entire breadth, so B divided by F. F is the distance moved in each rotation, each pass. So how many passes required will be found out by B by F. So this into B by F will be the time required to complete the cut. So that is and the MRR will be given as velocity into feet into depth of cut. So that's it in shaper machine. I hope the concepts, I am able to clear the concepts. So thank you for watching this video.